Okay, hello everybody. I hope you are well. Well, I'm Louise from community team at Malt, and today, I will be with you to enjoy this Malt Academy. And today we are super lucky and to have Mario and Dana. And Mario is in Chile now, and Dana in Texas, and I'm in Madrid. I don't know where are you right now, guys. If you want to share and say hello in the chat and tell us where are you right now. Let's see how international it's this talk and this Smart Academy. And yes, so today the webinar, maybe I will not tell the title. If you want, Mario and Dana introduce it, and just thank you very much to be here today with us, and just check if the attendees actually are hearing us and just see us. So maybe if some of you just can say hello to be sure. Okay. Hello, Thibaut. Thank you.
Hey, everybody.
Hey.
So maybe we can start. Thank you very much, Mario and Dana. And at the end of the talk, we will have some space to do some Q&A. You have the question there, and you can also comment on the chat box. And I will be there with you until the end. So if there is anything like a bug or something, I'm with you. Okay?
Awesome.
Are you ready, guys?
Thank you.
Let's start.
All right.
Perfect. Okay, yeah, let me kick it off. So first of all, welcome everybody. Good afternoon. This is going to be a very interesting talk titled "How CQRS and Event Sourcing Patterns in Typescript Could Change the Cloud Industry." And I'm going to admit right off the bat that sounds a little grandiose, but we have our reasons for calling it that. And in this presentation, we're going to be talking to you about the many benefits of CQRS and event sourcing, and also show you how you can start adopting these patterns using the open source TypeScript booster framework to build cloud native, event driven applications. So next slide, Mario. And before we go any further, I want to introduce myself. My name is Dana Peele. I'm the Chief Innovation Officer of a consultancy out of Spain called the Agile Monkeys, and I'm currently here in Austin, Texas. Next slide, please. And as I said, the Agile Monkeys is in Spain, specifically headquartered in the Canary Islands, the beautiful Canary Islands that everyone here should visit. And we have a brilliant team of engineers. We're distributed across Europe and the Americas. And we've been building distributed event-driven platforms for companies such as eBay, Rent the Runway, and Zara. And we've worked with institutions like Harvard University. So we have a lot of experience that we've brought to bear on the problems we're going to be talking about today. And I think you're going to find it incredibly interesting. And with that, I'm going to turn it over to Mario.
Yeah, so my name is Mario Castro, and I'm a senior software engineer at the Agile Monkeys. I've been working with the company for the past almost 2 years. And as part of the Agile Monkeys, I've been working mostly on consultancy projects for Harvard University. But now I'm dedicating most of my time to work on the Booster project that we will talk about in some detail shortly. And I also have a podcast that is also part of an Agile. It's also an initiative by the Agile Monkeys that's called Rocket to the Cloud. You can listen to it or watch it on YouTube if you follow that link. And you can scan that code and it will show you like all the different links where you can listen to our podcast. Okay, so. Now that we're not total strangers, let's look at what we'll be covering today in our talk. So first, we're going to provide an overview of CQRS and event sourcing, what they are, what they're used for, what problems they solve, their pros, their cons, and so forth. And we'll also be sharing, some of our experiences when implementing these patterns and the sorts of difficulties that one can face when you want to go down the CQRS and event sourcing route. And then we're going to introduce Booster Framework, how it came to be, and how it can help or aid organizations in adopting CQRS and event sourcing for developing event-driven systems. All while using a modern language like TypeScript, so facilitating, cloud-native deployment. And we'll also have an in-depth look at an actual Booster application. That's going to be the fun part. We're going to do some coding, and we're going to deploy it live and have it, test it. And then we're going to end our talk with an invitation for everyone to, try a Booster and so that you can build your own cloud native event-driven applications or even contribute to the project. So let's go start with the theory first. Okay, so CQRS and event sourcing. You've probably heard about these concepts before already, and probably often accompanied by other terms that are somewhat related, like microservices or event-driven architectures. And most likely, you've probably seen it with 3 letters, D, D, and D, domain-driven design. And you've probably also associated the whole event-driven thing with, stream processing technologies like Apache Kafka and, and all that sorts of things. But what we'll see is that at their core, CQRS and event sourcing are relatively simple patterns that don't necessarily have to be associated with these other concepts. I've just mentioned that. It's just that when they use together, they enable a lot of good things that are especially beneficial for enterprise-grade systems. Okay, so first, let's start with event sourcing. So event sourcing really is nothing more than just another way of persisting information and deriving the state of the different entities in your application. So to get a better idea, let's look at how we're used to persisting information. So I'm pretty sure that most of you in the audience are mostly familiar with the entity relationship modeling or object relational mapping, or ORM, way of doing things, which usually translates into tables in a database, right? Each one representing an entity in your domain model, and each row is an instance of that entity. Like, for example, a users table, right, that we have here on the slide, where we store a user's name, email, password, and it's a unique identifier or ID. And we interact with these entities through what we call the CRUD methods. So it's create, read, update, and delete. That's where you get the 4 letters. We create a user, which adds a row to the table. In SQL, insert user into users. We read the user's properties by querying what's in that row. Select star from users, etc. We update a user's property by updating the values in one of the columns for that user's row. And we can also delete that row, right? That way deleting the user from our system. So what's important to understand is that with this way of doing things, the only thing that's being stored in the database, or any method that you're persisting, is just like the current state. It's just like a picture of the latest, right? And in a lot of cases, I guess in most cases actually, this is just fine. But there are times when you want to know more than just like the current state of things. You want to look at how all of the changes have happened through time, right? And so let's look at what event sourcing does. Event sourcing, what you persist, whether it's in a database or an Excel spreadsheet or even a piece of paper, are the events or things that happen to entities in our system, right? So what you're storing is you're storing, like a picture of an entity, but instead you're storing like descriptions of what happened, right? And these events are persisted to an append-only log, which means that you can only add but not delete or alter the events in the log, right? So you just add events on top of each other. And this makes total sense because, as I said, events are things that happened. And because we have not invented time machines, we cannot go back in time and stop those events from happening or change them, right? So if we were able to do that, our information systems would give an altered view of the reality that we're modeling, right? So how does this translate into a practical use case? So let's deconstruct event sourcing, right? So we have events, which we already explained, and sourcing refers to how events are the source of truth of our system. So if we take all the events that are associated with an instance of an entity, which is usually referred to as the event stream, from the beginning of time and replay them in the order that they were persisted in the event log, we will end up with the latest state for that instance. So let's use the user's example, right? And consider the following stream of events, listed from oldest to recent. So first, you have a user that was created with ID 123, name John, email john@example.com, and password 123456. All right. And then we get another event that says that the email for the user with ID 123 was updated to johnny@example.com. And then later in time, another event came in and says that the password for user with ID 123 was updated to, that gibberish over there, right? So with these events, what information would I get if I wanted to know the recent state of the user with ID number 123? Well, looking at this way, it's kind of obvious. We would get that the user with ID 123 has the name John. His email is johnny@example.com, and his password is whatever it's written over there. And the key distinction to make here is that with a typical CRUD way is that we have persisted that, and unlike in CRUD, we have persisted the entire history of changes for that user. All of that is saved into our database, right? And this is valuable information that was previously lost, unless you model your system, your CRUD system, to be able to store those changes, but that's usually not the case, right? And looking at the way that event sourcing works, you probably might have connected the dots and realized that this is the method that is already being used in accounting and banking, only that they called it a ledger, not an event log. And the thing is, it has been used that way for centuries, and not only in banking, but in many other fields as well, such as legal documents, addendums, all that stuff that is added at the end of legal documents. Same idea. And there's a historical reason why in digital information systems we took the opposite approach of just storing the current state, right? And that is because not too long ago, well, yeah, decades ago, so disk storage and databases were like really expensive, and persisting too much information was cost prohibitive for most people, right? But fast forward, good thing is that in 2021 the opposite is true. Nowadays, storage and databases are cheap, relatively cheap, and we can store as much information as we want without burning a hole in our pockets, right? And let me also say that event sourcing does not directly associate to a specific database like technology. You can implement an event log, often referred to as an event store, with a relational database like MySQL or Postgres, or you can use a non-relational or document database, like MongoDB, etc., or even key value stores like Redis. And like I mentioned before, like people have been doing event sourcing for centuries by just using pen and paper, right? So what I want you to take away from this is that what's important is its core premise, that storing the events or changes to your system to derive the state of your system, right? That's event sourcing. So enough about event sourcing, and let's talk a bit about CQRS. And CQRS, it sounds like a really complicated, but it's really not that. So CQRS stands for Command Query Responsibility Segregation, right? And to better understand what this means, we should probably mention first that CQRS is derived from CQS, this other concept that was, I think, coined by this guy called Bertrand Meyer. He's the creator of the Eiffel programming language, I believe. And CQS is command query separation, which is a really simple principle that state that an object's method should be either a command that can mutate or alter state but does not return anything, right? Or a query, which does not mutate or alter state but returns data, right? And what we have is CQS on the left over here on the code, right? So you see that the command method is the one that's called change password. It takes the new password, but it doesn't return anything. It just changes, right? But then if you want to get the user's information, that's the query method. It doesn't change anything, but it returns the state of the user, right? That's what the query. And CQRS, it just takes it a step further. Whereas CQS refers to the separation within an object's method, CQRS is just basically taking that separation a step further by creating two sets of objects, right? Where there was once one for commands and another one for queries. That way you really segregate the responsibility. And that's what we're seeing over here. So on the left, we have CQS. It's just one class user. And if we were to turn it into CQRS, we would just have two classes. One called, user command with all the commands, command methods for the user entity, and for another class called user query for the query methods, right? And that's pretty much it. That's the essence of CQRS, and it's nothing at all complicated in principle. And in fact, I think it's quite the opposite. And CQRS, as you can see, it happens at a very low level, at the code level. But if you take that premise to a higher level and used in conjunction with event sourcing, it can provide a lot of benefits, right? So just thinking about separating the reads from the writes and that they cannot interact with each other, that can provide a lot of benefits, especially in complex systems that need to meet scalability demands, varying read and write access patterns, and changing business rules, as we're going to see shortly. So most of the time, you'll encounter CQRS and event sourcing being used together, probably in the same sentence, along with some other concepts related to domain-driven design, but we're not going to go into those in this talk, right? That, we could talk for hours on that. And the idea of, event sourcing, of a single source of truth in the form of an event log, and CQRS, the separation of the reads from the writes, they complement each other really well. And I know there are a lot of people from France, like garlic and parsley, like ail et persil. I hope that I pronounced that right. And why is that? This is because the model that is being stored or written is not the one that's being queried or read. The command or write side's only concern, it's going to be to validate the business rules and making sure that the events being stored are valid, right? Whereas the query or the read side, the other side, is only concerned with replaying the events and modeling them as entities. And events, another word for events could be facts, right? And they can be interpreted in many more ways than one, depending on the context, or borrowing a term from domain-driven design, which is the ubiquitous language of the business unit. And this is why many complex systems adopt CQRS and event sourcing. Since events are an as-is representation of reality, which can be interpreted and viewed through the different lenses of each business unit, rather than making use of fixed data model that can make sense for some business units, but not much for others. Okay, so let's talk a bit about the pros and cons, or things that you need to watch out for when you want to go with CQRS and event sourcing, right? So first, let's start with the pros. Let's start with the good stuff. Full history of changes stored in the event log, right? So as I mentioned before, storing every interaction in your system as an event, that's going to give you a complete history of everything that went on in your system, right? So by default, this gives you auditing. And there are some use cases, some industries, for example, finance and banking, like I mentioned before, where auditing is a must, it's a requirement. So event sourcing is a natural fit for these sorts of use cases. And, these same auditing capabilities can be a real advantage, in terms of error handling and debugging. So that will make, developers' lives a bit easier, right? And the other powerful use of the full history of events is the ability to infer data from them through the use of advanced analytics or fueling machine learning models. So I want to illustrate this with an example, right? A good one is like a shopping cart, like on Amazon.com, right? In a regular, CRUD-based system, you only know which items were in the shopping cart at the time that it went to checkout. But if you model every interaction with the cart, like creating the cart, and then you add items, and then you take out some items, remove some items, and proceed to checkout, then you can see the full history, and maybe you can notice some patterns. Like, for example, there's a certain price threshold that shoppers have before removing items from the cart. If you notice these patterns, that can lead you to more informed business decisions. Like, for example, if you notice that people are, crossing that threshold, you can then provide a discount or something that the system infers because the person is removing stuff because all of a sudden they think that it's too expensive, right? So that sort of information, it can become really valuable. And another pro, loose coupling and scalability. Being able to separate the reads from the writes, provides a way to optimize them separately and scale accordingly. Most systems have an imbalance in the read to write ratio, So with event sourcing and CQRS, one can, for example, store separate read models for different use cases. They act like caches that don't affect the performance of the commands, right? So you're not gonna be having database trouble, when you're trying to update the system if there's like a billion requests, trying to get information out of it, right? Because they're going to be separated. As a matter of fact, these read models can actually, in practice, a lot of times they can reside in different databases or even data stores. That, for example, you can have the right side, you can have it on a relational database, and then you can have like a MongoDB or a document database for the reads. And this is exactly what we'll see that Booster Framework is doing. And as I probably mentioned previously, this decoupling can benefit complex systems, right? Because the complex systems, there are different businesses, have their own different views coming out of the same source of truth, right? With their separate read models that don't interfere with each other. Okay, so that's for the pros. Let's talk a bit about the cons, or the things that you need to be careful with. This is eventual consistency, and this is a big one, and this is probably one that you're probably going to see mentioned a lot with regards to event sourcing, right? So event-driven applications, they are asynchronous in nature, and those using event sourcing and CQRS are no exception. This asynchrony manifests itself in eventual consistency, right? And the textbook definition of eventual consistency is a consistency model that does not guarantee immediate access to updated values. So which means that after submitting a command, we shouldn't expect the updated value to be reflected immediately after querying a read model. And the key word here is immediately. So most of the time, it's fine if our changes are not reflected instantaneously. They will eventually, that's eventual consistency, they will eventually be reflected. And by eventually, most of the time we mean milliseconds. So it's usually not a problem. But if the changes are not reflecting, then we're in trouble, right? And the key thing here as well is to not leave business decisions to part of the system that are eventually consistent, because that could induce bad events being stored in our event log. And an example of this is, for example, running a command and then checking if there are enough sufficient funds in that in like a bank account, right? For example, if the system is eventually consistent, and for some reason there was an event that took money and left it without funds, but then the command wanted to take out more money, but then when it queried the current state, it told them that it had money, then we're going to be having like double spans, and and then we can get in all sorts of trouble. And the other con that we see sometimes is that performance issues during event replay, right? So to derive the state of an entity, remember, this is an append-only log, right? This is just stuff where you just put things together and just some big list. When you want to derive the state of an entity from a stream of events, you need to start with all of the events from the beginning of time, replay them, and process them. And yeah, on a small case system, this is not an issue, but event-driven systems usually have thousands, if not millions of events, right? So you could get the idea that processing all of the events might not be a good idea if we don't want to hamper event logs performance. So a solution to this issue is by using snapshots. So snapshots are basically periodic reconstitution of states that are saved. So that way, the next time that the state is reconstituted, right, you don't start from the beginning, but you start from like a point of time that is a lot closer, right? Which is the latest snapshot. That's one way to work around this issue. Okay, and this is some difficulties that we've come across, and a lot of people have come across when implementing CQRS and event sourcing in their system, right? And we're going to highlight these ones because these are the ones that we want to tackle with by constructing Booster Framework, as we'll explain shortly, right? And first, cloud infrastructure, right? It's 2021. Most of the time, most of the stuff that we're going to develop is going to end up in the cloud, right? And there are many architectural design choices and decisions, that need to be made when attempting to run an event source system on the cloud, right? There are decisions to be made as to which is the right event store. What other databases might better suit the read model, right? Which compute platform to use for running your microservices for, I don't know, do I want to use serverless functions, or do I want virtual machines, or do I want everything as pods in a Kubernetes cluster, right? How do you communicate between these services? Do I want to use like an event processing platform like Kafka, all those sorts of things? And we haven't even discussed pricing, and that's when, as they say, shit hits the fan. And dealing with cloud architecture sometimes feel like a daunting task, and it's a big barrier to entry to adopting more sophisticated architectural patterns, right? As you scale from a few hundred events to thousands and millions, and bottlenecks begin to form, machines run out of memory, request limits are hit, technologies that once worked perfectly start to fall over. You need to shard databases, partition streams, scale everything horizontally. It gets harder and harder to maintain performance and availability. So yeah, dealing with the cloud, that's a big pain, right? And also, one that we found is that there's a lack of opinionated tools that facilitate adoption, right? And there are very few tools that help you on your journey. And the ones that do exist, they're specialized for like very specific tasks, and they require like careful configuration and deployment. And a lot of times they cost money. So all of those difficulties presented before, they're real. We've experienced them in some way or another during our years of consulting work at the Agile Monkeys. So we came up with the idea of developing an open source tool that can facilitate adoption of patterns like CQRS and Event Sourcing, while at the same time being cloud native and being able to scale and handle production workloads, right? And the result of that initiative is what we like to show you now, which is Booster Framework. It's an open source project under the Apache license. So let me tell you a bit about it. Right. So Booster first is an opinionated framework, much like Ruby on Rails, right? Or Spring and, many others. But has, additional features and advantages. You can build TypeScript applications that run natively on the cloud. That's why we have, the cloud icons over there on the slide. And follow, the CQRS and event sourcing patterns. And for developers, this is the whole part about the developer experience, right? We took a lot of care in that. It helps you focus only on modeling your domain events and business code by not having to worry about the underlying cloud infrastructure, right? And we're going to see that in action in the application that we're going to build shortly. So it will infer the right cloud infrastructure from the code, and it will take care of provisioning and deployment. So, all right. So enough about what's it about. So let's get into the coding portion. But before getting into the actual coding, let's describe what we'll be coding and how we're going to attack it, right? So this is the use case that we're going to be doing today. We're going to code the backend for an application called ask.me. And so in ask.me, people attending a conference or a talk like the one that we're in right now, they can submit questions. They can, like questions, so that way you can sort them by popularity. And, there should also be a way to create new conferences. Those are like the three actions, or as we'll see shortly, commands that this system can do. All right. So let's step back for a bit, right, and think first about let's apply, CQRS and event sorting. So what kind of events will end up stored in our event log, right? So I just said that users or applications should be able to create a conference, submit or ask a question, or like a question. And recall, events are things that happen to our system. So the events that will end up stored in our event log, should be in the past tense because they happen, right? So what follows then should be, kind of obvious. Create a conference created. Submit or ask a question was asked. Like a question liked. I feel like I'm explaining like a conjugation of verbs in English instead of doing actual computer science, right? And every event stored should have some relevant information. So like in the case of conference created, we should not just store that, a conference was created, but we should also store that a conference was created with a name and, for example, like a location, right? And when someone, asks a question, we should store, the question that was actually being asked, give it some identifier, maybe identify the person who asked it and in which conference that question was asked. Same case when someone likes a question, right? We should store probably which question was like identified by its ID and who liked it, in case we want to identify the person. So those are the events, right? But events don't come out of thin air. They must be the consequence of some action, or yes, you probably already guessed it, a command, right? The C in CQRS. So if events are formed by verbs in the past tense and the predicate, then the verbs and commands are in the infinitive form, right? So conference created event, the command should be create a conference. A question was asked, ask a question. Question liked, like question. And just like the events, the commands must have some relevant information. It is when commands are being submitted that we can perform validations, right? For example, when a conference is being created, our command handler should check that for example, it has a name so we can identify it. And or when a question is being liked, we need to check whether that question exists, and so forth. Okay, so we pretty much, with that taking care of modeling, the right side, defining, how we submit information that was stored in a append-only log. So let's talk about, the read side. That's the one that we want to look at over here, because we want users to be able to see what questions have been asked, right? Otherwise, this application that we're making here is pretty useless. So let's not think about events for a minute. Instead, think about what entities make up or asked on the application. So I think it's safe to say that our system is made up of questions and conferences, right? Those would be like the two entities that would make up our system. So in a traditional, CRUD method, there would probably be some database table called conferences, another one called questions, and probably another one for the likes, with all the necessary foreign keys indicating relationship between them. But here, instead, we have all this information stored as events, right? In just one single event store. And since we're not tied to a particular database schema, this is actually one of the advantages that I mentioned before, right? So we're free to shape our entities as we like from the events. And this goes back to what I talked about, loose coupling and how from the events, different business units can form different entities from the same data. For example, I want my question entity to have a property with a likes count, but maybe there's some other team in the organization that might want to instead rank questions by the word count, right? So instead of likes count, it has a word count instead, right? Okay, so let's review a bit, how this translates into what we're going to build, with Booster, right? And how the data flows in our backend application. So we'll start our front end, right? Could be a mobile app or a web app, is going to interact with the backend through GraphQL queries and mutations, right? So starting with a GraphQL mutation, a user can submit a command, which is then processed by a command handler. The command handler is going to perform any necessary validation that I talked about before, or apply some business logic. And then that's going to register an event to the event store. That's the cylinder that you're seeing over here, right? So remember how I said that an event is a consequence of an action? In this case, a command, right? So to the right of the event store, we have event handlers. So this handler can listen to specific events and take some action, behaving like a command or even registering other events. So for example, remember that shopping cart example that I mentioned earlier. Imagine that when you remove an item, an event called item removed is registered. And there's an event handler that whenever that happens, is going to send that person an email reminding them to consider buying that item. I know that from experience because Amazon does that to me all the time, right? And when we have events, we have to take an event stream and reduce the event. That is to take all of the events in the event store related to an entity ID and apply a reducer function that corresponds to the event being reduced. So for those of you that might be familiar with functional programming, think of it as a fold left of a list, but the list is made up of events and it applies a different function depending on the type of event and encounters when folding the list. And when you reduce the events, that gives us our domain entities. And the way that we expose them to be queried is by creating projections of them in the form of read models. Now, remember how we said that in CQRS, you can optimize the read side by having separate models specific to querying? Well, that is actually what's going on here. You can project entities as is, right? Or you can manipulate them as you see fit, depending on how and what you want to expose to the in this case, your front-end application, your mobile app, etc. So in this diagram, the only things that we're going to be coding with Boosted, that's why it makes things a lot easier, are the rectangles, right? That will be the command handlers, the reducers, projections, and event handlers. And what's so great about the rest of the components is that they're inferred from the code, and the framework takes care of provisioning and deploying, as we're going to see right now. Well, we're going to get into the coding, right? All right. So let's code. I'm going to close my, and let me open my terminal. All right, let me make it bigger so you can all see. All right. Okay, so let's start coding. So first things first, we're going to create a new Booster application. So first things we should probably do is install it with npm. It's TypeScript, Node.js. npm install it globally. That's the name of the package. Let's install the CLI tool. And then, it's going to npm do its thing, download the world. Hopefully it won't take long. I think my internet's doing just fine. And once we have it installed, we're going to create a new project. So I talked a bit about developer experience. A big part of it, developer experience, is providing, these sorts of tools like CLI to generate boilerplate code and all those sorts of things. All right, so we have it installed. Let's check that it's installed by running the boost command, boost version. Great. Latest version installed. All right, so let's create a new project. And we do that by running boost, new project, right? And let's call this one Malt Academy, because that's the fine institution that is having us do this talk. Okay, so the description asks me, all right, so what is the first version? Yeah, the author is going to be me. No website, license, yeah, MIT, URL. Okay, so this part's important, right? As I said, we want to be able to deploy this to the cloud, right? So we need to tell the framework to which cloud provider we want to deploy our code to. Currently, AWS, it's fully supported. Azure and Kubernetes is still experimental. There's still an support for other cloud providers like Google. That's down. That's on our roadmap. So we're going to go with AWS because that's the one that works perfect. So what's it going to do now? It's going to create all the necessary folders and files that are needed to get started with a project. And installing dependencies. It's just running npm install in the background. All right. And it'll end up shortly. And once it does that, we're going to open our IDE. Some dependencies. Oh, see, there's a lot of action on the chat window, which is cool. All right. Okay. Project generated. Let's go over to the Malt Academy. There's a project, and let's open our IDE. I use WebStorm. You can use VS Code. I like WebStorm, made by the fine folks over at JetBrains. And preparing workspace. There we go. Okay. So this is what a booster project looks like once you've generated all the standard boilerplate. So as you can see, the directory structure, it maps directly to the stuff that I told you that we'd be coding, the rectangles in the presentation. So we have commands, entities, event handlers, events, and read models, and some other goodies like schedule commands and, some common files that you can have that, but we're not going to go into detail. We just want to, stick to the simple Ask Me app that we're going to be coding today. And then you have your config, right? And in your config file is where you can, set up the different environments and the different providers. Here we're using the AWS provider to deploy to AWS, but if I were to include the provider for, say, Microsoft Azure, I can add another environment over here so that we can use that one. But we'll see that later once we get into the deployment part. So, all right, let's start with let's start creating some code, right? So these directories are empty. Let me open up the terminal over here so I don't have to switch to the one, and let me make the font a bit bigger. And let me make it a bit bigger over here. No, way too big. That's better. All right, so let's start by creating commands, right? So remember the commands that we had for creating a conference, asking questions, and liking a question. So let's do one called boost new. We're going to use the CLI for creating all the boilerplate, right? New command, create a conference, right? And here I'm going to tell you that our create conference commands is going to take, two fields, right? One is we want the name of the conference, which is going to be a string, obviously, and then a location so we can identify where the conference was. And let's do that with a string. And it's going to run that. It's going to do its little magic. There we go. And now under our commands directory, we have a new file called create conferences. No, I don't want to add them to Git. Thank you for asking. And here we go. And this is what it looks like empty. And we're going to be, filling in with our code over here, right? And let's take a look a bit at the code. So how Booster works, is by using the Typescript decorators. For example, what this one's telling you that this create conference class it corresponds to a command. In that way, the framework can then infer all the different things once it comes to deployment time. And this authorized part, we're not going to get into that for this talk, but this is basically how you can have access control. You can create like different roles. For example, if you want to have some commands that are restricted to some specific roles, you can do all of that over here. But for now, we're going to just basically have it for everyone. Okay, and here a constructor. These are the fields that I passed to the CLI, our name and location. And here is the command handler in which we can do our validation, right? So let's add some validation. So first, let's check that the command has that it has a name, right? So, oh, sorry about that. So if it doesn't have a name, we're going to throw a new error selling conference must have a name, so that way they can get the idea. All right, and first let's check if there's already a conference with that name. So what we're going to do is check, for the latest entity. Well, sorry about that. This is live coding, with all its mistakes. All right. And we're going to get some errors because I haven't created this one. No, this one exists. So this is part of the framework core, but this entity does not yet exist. We need to, we're going to define it, in a short while. And if we have a conference, then we need to throw an error because we can't create one with the same name. By that name. And then once all of that is done, we register the event, right? So after passing all our validation, making sure that the command is sound, we say we return a new, and so this is create conference. So there would be a conference created, and okay, and in this event, we're going to store the commands, the name of the conference as an event, and the location. Okay, so we're still getting a lot of errors because this doesn't exist, and the event, we haven't defined our event yet. But let's do that using the CLI. This new event, we're going to call it conference created, and it's going to have the same fields, right? But we're going to say we're going to store the name from our command as its conference ID. So we're going to use that as its unique identifier. And then we're going to also store the location as a string, right? Conferences. Oh, there's a typo over here. Sorry about that. There we go. All right, and then we have our event over here. See, conference created. Wait, don't ask again. Here we have our event. And this is the code. It's very simple. So basically what we're telling here is that this is the shape of our event. It's going to have this conference ID that's going to map to the name that we get in the command and also the location. And this function entity ID, this is the one that what we do here is we tell it that our conferences are going to be identified by, in this case, the conference ID, right? Okay, so, and now we can import it over here, and we're getting a lot less errors. But we're still missing the conference entity, which is one we're going to get to right now. So now that we're storing a bunch of events related to a conference, let's see how that maps to an entity. All right, so we're going to go back to the CLI to generate the code. So that way we're going to get a file over here under our entities directory. So new : entity. We're going to call it a conference, right? And our conference is going to basically reflect that, the same what's in the event, right? It's going to be really simple. So once we get to the questions, things will going to look a lot better. And it's also going to be a string location string.
Do you want to make that conference ID with capital D to match the other one, or?
Oh yeah. Thank you, Dana. Sometimes, all right, conference ID, location string, and this flag reduces. So remember that in our entity, what we're going to do is take all the events that are associated to whatever entity ID identifying a conference, right? And we're going to apply a function. So you can, with the CLI, you can pass, if you pass the reduces flag, you can tell it, okay, so I want this entity to reduce a conference created event, which is our event that we have over here. Okay, so let's see how that looks, right? So, okay, we have our entity, so we have our conference, and it's also pretty much empty. Oh, I forgot. Okay, so this is redundant. So the ID over here. conference ID, it's a bit redundant. I think we're gonna have in trouble. Conference ID. Okay, so event conference create. So okay, so this is the reduce function. Remember, the decorators, nothing more than telling it that this class conference corresponds to an entity, but this decorator over here is telling us that, you know, whenever we encounter a conference created event, okay, we're going to apply this function that is called reduce conference created. The name doesn't matter, but just the decorator, it's enough to tell it that, you know, what function to apply, right? And once it applies this function, what are we going to have? So this is the this is the created event, so it's the one that's going to happen first. So we don't need to check if there's a current conference, right? So what's going to return is just a new conference, and it's going to return the event, the conference ID for the event, and the location. All right. And now we can go back over here and import this one. There we go. Okay, so now our code is error-free. Yeah, but conferences are not very exciting. So let's get to the questions. All right, so let's start with the commands for the questions. Let's go over here. Let's head over to, okay, so now we're able to create a conference. By the way, this is all, we're going first with all the stuff on the right side just to get things into our event store. Then at the end, I'm going to look at the read side, right? Okay, so let's start with the question. So let's create a command so that we can ask a questions. We just call it ask. And okay, so what are the fields that we're going to pass to this command? Let's say, so who asked the question is going to be a string. The question itself is also going to be a string as well. The conference, this case, we're identifying, but the conference ID is just the conference's name, so it's just a string, right? And then we're going to have the front end pass in an ID. All right. Okay. Okay, so there we go. We have a command over here for ask. And while we're at it, let's create also a command for liking. So for liking a question. So we're going to call it like. The fields are going to be the question ID. It's going to be a type UID. And then we also want to know who liked it. We're not going to create a unique user with a unique ID. We just want to just have like a string with a name, right? So there we go. And we have our two commands over here. So ask and like. Okay. So same thing. We're going to let anyone, call this command method. And then we need to do our validation over here. So to keep things, going faster, just going to copy and paste some code I have over here, so we can get things, going. All right. Wait, what happened? Oh, that's it. There we go. Just taking care of all the dependencies. Yeah, whatever. All right, and that's pretty much it. So once we get over here, we need just first. So we need to know who is asking the question. That's a business rule that we're imposing. Same thing. There has to be like a string for the question. We need to check that the conference exists, and then if there's no question ID, we're going to assign one for it. This is totally optional. You can, and then once all that is done, we're going to, register a new event that is called question ask. So let's create that one with the CLI. question asked event. Okay, I'm going to be copy and pasting so I don't type that much. So case, new event generated. All right, so the same thing in our event store. What we're going to, the information that we're going to end up seeing is the question ID, when it was asked, right? This does not come in the command. This is something that we set once we handle the event. I mean, once we handle the command, and then the question, the conferences, and the text of the question, right? And we need to give our question, what's the ID of our question? This is like kind of like saying like this column is the primary key and your regular database. In this case, is our question ID. And there we go. Okay. And let's look at our like command. Okay, so now this one should work. And printer should give me no errors. There we go, formatted. Same thing with the like command, right? And then this one, we only need to check. We want, again, everyone can ask, can like. And then we need to check that we need to at least have someone telling us who liked the question and giving us the ID of the question. And that's pretty much it. Except that we don't have a question liked event, which we're going to create right now. All right, there we go. Question liked. Let's create it. And question liked, identifying who liked the question and which question was liked. There we go. Events. Oops, sorry about that. Question liked. Same thing. It's going to apply to the same question asked. Since all of these events, question asked and question liked, apply to the question ID that we're going to work on right now, shortly. They map to to the same entity ID, right? And this question ID. Let's format. Okay, so this looks good. This one looks good, right? And let's go back to our like command and let's import the class format. All right, cool. So now we have all the commands, and we've already taken care of storing things on our event store, right? So let's move over to now shaping our question entity. So that way we can have, and that way we can then query, the conferences and the questions. Sorry. And for that, let's create the entities over here. So, all right. This is the new entity, which is over here. Our question. So how are we going to shape our events? We want to, have a field telling us when the question was asked on, which is going to be a string with a date. The conference ID. In this case, is going to be, just, the name of the conference. Questioner, the person who asked the question, the text, the body of the question, and then this is the one that we're going to calculate now based on the events, the likes. So pay attention to this one. This one is a number. So this is, I guess, where the magic happens, so to speak, with event sourcing and reducing the event store, right? So let's create a thing over here. All right. Okay, so we have our question entity. And now we need to create the reducer function. So remember, we're going to use reduces decorator. Let me import it. So the first, let's start by, before liking a question, that question needs to be asked. So question asked. All right. But there we go. And then we're going to public function. No, wait, no. Sorry about this. I'm getting mixed up my languages. asked, right? Oops, sorry about that. Wait. This is... I'm just going to go copy and paste the code, right? So we can just go and explain it. Okay. So when the question was asked, right? So we're going to get the event that started it all when the question was asked. We're going to our entity that then is going to get the ID that was stored in the event store, the when, same thing with the conference and the questioner. Wait, why is that? Poverty question is the last question asked. Oh, sorry about that. Wait, where is this question asked? There was a typo over here. And sorry about that. Okay, the text of the question, and it's going to start with 0 likes, right? That's because when this event comes, that's the first one that started it. And let's now do with our other kind of event, which is question light, right? So this one that is the one that's going to process the likes. So first we need to check, so as I remember, this is like a fold left, right? So once it encounters this sort of event, the framework is going to then decide, okay, so it's a question light, okay, let's apply this function. So if there is no current question, right? So, that doesn't exist, so it just throws an error. But then what are we going to do? We're going to return a new entity, but this entity, is going to have the same value as the current question, right? Except that we're going to be adding likes. So every time there's a question like for this entity identified by this ID, is just going to be adding more and more likes. And, this is going to be accumulating the value. All right. Okay, so pretty much taking care of all of most of the right side. So let's now have a read models because, oops, sorry about that. So if you recall, only our commands had this authorized part over here. That is because these are the methods that these are the parts of the system that are accessible by our front end application. There will be the commands, and for example, you can access the events or entities or anything, right? But you can with the read models. So let's take a look at the read models, and let's create that. So with the read model, we're sort of like creating the contract by which the users can query our information in our system. That way, they can query. This is like the select star of our system, right? Or our find all. So let me go back and copy and paste my code to make things go smoother. So first we're going to create a read model for conferences, right? So this one's going to project a conference by its ID, and the fields that we want to bring are its ID. That one's by default, right? And which is the name. And same thing with the location. So let's create the read model over here. Okay, and our read models over here is going to end up populated. And let me just create the same one for the questions before looking at the code. All right, same thing, a new read model for questions, right? And the fields are going to be pretty much the same ones that are found on the entity, right? But there are times that you may want to manipulate. You can change the name of the properties, or I don't know, maybe do some text formatting or max some information. If you don't want to return like sensitive data or that sort of things. That sort of thing is done over at the read model level. All right. Okay, so let's apply the CLI. There we go. Now we have our two read models. And we're almost at the end of our journey. So with this, before deploying and actually seeing this thing in action, right? All this the stuff that I've been talking about all this time. Okay, so let's take a look at the conference read model. Same thing. We're going to give it access to anyone. We're not going to care about permissions and those sorts of things. And what we're going to return here, here's where to find a read model, the way its shape, I guess. And what we want to return here is just basically a new that is going to made up of the entities ID, right, and the entities location. All right, that looks good. Okay, so let's do the question read model, which is one over here. And this one's going to be, pretty much the same. So it's going to return it as is, right? Okay. What's complaining about that? And that's it. So now a person can, run a GraphQL query asking for the question read model, and passing it its ID, and then get all the information that we want. In this case, the ID, when it was asked, the name of the conference, who asked it, what the question is, and the likes count. Phew, okay, that felt like a lot of things. So all of the coding is done. Let's get this thing on the cloud. All right, so let's go back to the config. By default, it gives you an environment called production. Let's just use that name. So with that name, what we do is we do boost deploy -e, and then production. All right. And what this is going to do is going to look up in our configure file, production, which is that one, which provider is it using? Oh, it's using that provider. That provider, which one is it? It's AWS. I already have my AWS credentials configured in my machine, but that's it's like a previous step that you probably have to take. Same thing, with Azure and Kubernetes, it's all in the documentation, by the way. And once we do that, click enter. And it's going to do all the deployment magic. In the meantime, while that is happening, I'm going to paste a URL on the chat window so that you can access. I'm going to paste the URL of the front end. All right. So okay, there it's using CloudFormation and all that AWS mumbo jumbo to get this thing, working on Amazon AWS. All right, so everyone, I just pasted a URL on the chat. It's called Ask Me Some Gibberish on DigitalOcean.app. Now, if you visit that URL, it's going to look something like this, right? And in this one, once all of this CloudFormation things is finished, is going to return the API endpoint by which we can use to run queries, right? So, this deployment part can take a lot of time. So I've already pre-deployed an environment. So let me go back over here. All right. So if I paste it over here, and now it should load conference, but there are no conferences because it's empty, right? So let's go over here to, let's use Hopscotch for GraphQL. Let me paste that. That's connected. It's going to load now our GraphQL schema, right? And we're going to create a new conference by which you can all interact with and ask questions, right? So we're going to do a mutation. All right. And okay, our mutation is our command method. In this case, it was create conference, and our input data, it's going to be, okay, so it was name, if I recall correctly. We're going to call it Malt Academy event, and we're going to pass our location. We're going to say the internet. All right, so let's run this mutation. And yeah, create conference was true. It's not supposed to return anything. CQRS, remember, this is a command. It's not supposed to return data. All right, and once that conference has been created, and if I go back to our front end, it should be, wait, let me reload the page because this is using local storage. Right now, that's not the one. There it is. All right, it's loaded. Okay. And now with that, I can enter front end. All right, great. Okay, so I'm going to copy and paste this on the chat window. Oh, where's the chat? Oh, it's over here. All right. So if you take that and you paste it on the on that welcome screen over here, then you should be able to select the conference and then enter it and ask questions. So does this thing actually work? Let's hope so. Yeah. I always think it like liking your own things. That's not something I like to do, but I really like it that this thing is working. So I'm gonna add a lot of likes. And for GraphQL queries, if we run it over here, then we see that the question that I asked is it has the likes count. It's adding them, and it's all using event sourcing behind it. Okay, so that's it for the deployment. Actually, now we have that's the GraphQL URL that I told you about. So maybe we can try that one, so that way you can see that this thing, it went live, while we were at it. Okay, and it went. Let's create a column. Let's call it 2.0, so that way you can see the difference. Okay, let's go back to our backend. Let's paste the backend URL over here. Ah, it works. Okay. Ah, it works as well. Let me go back to the other one. So have you people been asking questions? Please don't be shy. Okay. Let me just go back to the other one. And
And thanks a lot, Mario. And I guess then
okay, so I feel kind of lonely. Does anyone want to ask something?
Mario, do you hear?
No, that's fine. Okay.
Yeah, we can hear you.
Okay, cool. No, yeah, I think you.
No, I'm just talking about that. The only question over here is mine. Is anyone having trouble? Dana, if you can maybe.
Sure. They've been asking questions on the chat, so maybe they used up all their questions. But yeah, no, for sure.
Okay, so yeah, so I'm going to ask something that I don't want to start a flame war right now. Hey, test. So who is going to win Euro? That's it. All right, so yeah, that does it for the coding part. Let me get back to the presentation now. Okay. Let's go back. Oh, no, that's not the one that I wanted to show you. It's all right. Okay, so let's recap because we've seen a lot, and I feel like I've been talking too much, and that we've seen lots of things. So let's just do a quick recap. So, okay, so we've discussed CQRS, event sourcing, pros, cons of these patterns. How can they be beneficial for cases when you need, scalability, loose coupling, complex systems. And if you're interested, and if you want to go deeper into this pattern, there's a whole body of work that you can check out. What I recommend, for starting out is this book that's called Exploring CQRS and Event Sourcing. And that one's free to download from Microsoft's website. If you scan that QR code over here, I did not put the URL because it's some, funky URL with a weird character. But if you scan the code, you can get a link to download the book free of charge from Microsoft. And also highly recommend checking out, many talks by people like Greg Young, Martin Fowler, and others on the subject. You can find them all on YouTube. And, since domain-driven design is very related to CQRS and event sourcing, I also recommend all of the domain-driven design literature, like the Blue Book, the one by Eric Evans, the one that started the whole domain-driven design thing, and also recommend the books by Von Verden, which are more more direct. The problem with those, a lot of times they focus on the tactical aspects and of using, what do you call it, like object-oriented paradigms, those sorts of things. Okay, and also what we looked at is, Booster Framework, and in case it was not obvious, this tool makes it easier to start adopting CQRS and event sourcing by providing an opinionated framework for developing Typescript applications that use these patterns, right? And one of the key advantages of Booster over other toolings that, as you just saw infers from the business code, much of the wiring that goes under the hood to get an application up and running on the cloud, right? We saw this on AWS. I did not show you, but I have this also running on Azure. And this alleviates a lot of the work and effort required. And, that increases productivity. And as a consequence, organizations, can ship product quicker and with a faster time to market. And now, Dana, I want to hand it over to you so that way you can, tell us the final words of this talk.
Yeah, I wanna go really quickly here because I want to get to some questions, and I know we're almost out of time. But the long story short here is that tools like Booster, and you can see from some of the questions in the chat, are kind of overdue. And there's some things in the market, to help with event sourcing and to handle things like like some of the questions, optimistic concurrency, handling changes to events and models when they're supposed to be permanent. How do we handle those sorts of things? There's a lot of different issues with some of the existing tooling out there, and Boosters are our attempt to take all the problems that we've experienced, which are the similar problems to the ones that you're talking about, and put that into a framework so that we don't have to reinvent the wheel. We don't have to kind of figure out answers to these things ourselves. So next slide. So, I think what we really are looking for right now is collaborators, right? This is an open source project. We have a bunch of developers that are working on this. We have other developers outside of the company that are working on this, but it's only going to be as good as the community that adopts it and supports it and contributes to it. And so, we'd love for you guys to try it out and give us feedback. With even more love for you guys to contribute and provide some some work and some code of your own. So the next slide here. So yeah, it's on GitHub. If you go to booster.cloud, you'll see kind of the site, and you'll be able to get there from there. And then it's obviously pretty easy to Google as well. And the goal here, moving forward is really making this even more utilitarian, right? Being able to use this in multiple clouds, being able to use this locally, and then building out chunks of framework, which we call rockets, to be able to be able to deploy an entire site or an entire piece of infrastructure without having to do more than configure it. The next slide, Mario. And as I just said, these are like plugins, right? These rockets, and so we already have plugins for batch support for using Kafka, and again, like these are pieces of functionality written in the language. written in Booster and deployable, but they can be deployed on their own without using TypeScript as the overall language for your application. They can plug and play with existing functionality and really add a tremendous amount of value. Next slide, and then here, here's how you can contribute. You can click on you can use the QR code. You can go to any of these these sites. Join us on Twitter. Join us on GitHub. Join us on Discord. And we just love to continue the conversation there. And so now with a bit of time we have left, let's turn to questions here. So Mario, I think one of the questions that we didn't answer, and I wanted maybe you can weigh in on this, was around what are the tricky things with event sourcing, which is what if I want to change my model? Like what if I have a bunch of streams already? I have a bunch of events, and now I suddenly want to make a non-backwards compatible change.
I lost sound. Sorry, I can stop hearing you.
Okay, can you hear now?
I'm sorry. I think my speakers are having a problem.
No worries. So I can answer that myself actually. So we absolutely TypeScript actually lends itself very well to being able to cast things and to be able to change these models. And so we have actually built that out. And you have the ability to have transformers and to be able to transform the events that are coming out of your stream so that they can be handled in terms of the new model that you're using, even if they're not backwards compatible or forwards compatible, to be able to handle situations like that. Are you back, Mario? Okay, cool. So Alan, you joined in. You have other questions?
Yeah. Hi guys.
Hey, nice to hear your voice.
Thank you that you invited me. So yeah, I noted down a bunch of questions. I think I will start with more general ones.
Sure.
So can you tell me what is underlying event store?
So right now, I think the basic implementation that we're using is DynamoDB. And so, it's a plug and play thing. So you can use a lot of different technologies. But right now, the AWS implementation uses Dynamo, and there's different implementations for Azure and for other things. So it's not that complicated. Mario, do you wanna speak here and add some information there?
Sorry, Dan. I don't know what's going on with the audio, but I could not hear you, but I could hear Alan's question. So I don't know what I saw your mouth moving, but I don't. So I just lost whatever you probably told him.
Maybe Dana will try to reconnect. Maybe this will fix the whole conference.
Yeah. Well, what can we do about it? Only thank coronavirus for having to do these sorts of things using these platforms.
So basically, as I understand, the event store changes depending on the underlying cloud platform, but the feature set should be the same. Or are there differences?
Yeah. Oh, well, yeah. For example, on AWS, we're using DynamoDB with all its features and all its advantages. But then we can use the same one on other clouds for obvious reasons. For example, on Azure, we're using Cosmos DB, and this is where it gets interesting because when you start to use Kubernetes, for example, you can run it basically on any cloud of computers, Kubernetes cloud that you can have on a managed services like EKS, AKS, all the ones with the Ks that all the cloud providers have, or you can even have it on an on-prem infrastructure, right? So there are more. I guess if you were to go down the Kubernetes route, I guess you're more free The experimental provider that we're using right now, we're using for the event store, we're using a key value store, we're using a Redis, right? But that's something that, since as we mentioned, it's experimental. It's still something that we're evaluating, which would be like the correct one. But for the one that are natives to the different cloud providers, yeah, the choices there are, I guess more obvious, so to speak. So like Cosmos, same thing with Dynamo in AWS. I forgot the name of the one for Google, but I think it's Firestore. Yeah. So I hope that answers your question. Sorry.
Yeah, definitely. Thank you. The next question. Oh, just a second. Few weeks ago, I found out there's this Axon framework. It's Java Event Sourcing framework, and they released something called Axon Server, which is basically a combination of Event Store and Event Bus and everything you would like to have. So maybe you could consider to support it. Just yeah. But okay, but my another question is: do you support? You have those event handlers, but do you support something like more of process managers, the stateful listeners that can make decisions based off their state?
Dana, do you want to answer, Alan?
Can you ask that again, Alan? I'm sorry.
Sure, of course. Do you support something like more of sagas or process managers? The naming is not important. Basically, I'm asking about stateful listeners that can make decisions based on their state.
So are you saying like so like handlers that are handling other events being produced, or I'm just a little confused on what you mean by stateful listeners?
Okay, because as I understand, your event handlers, for example, can run other commands. Yeah. So basically, is that correct?
So there's command handlers and then there's event handlers, right? So
yes,
command handler,
of course.
okay.
Of course. Right. Can event listeners run commands, like create command and run it, dispatch it?
I see what you're saying.
Yeah, because there's this notion of process managers in event sourcing community that can run commands when something happens, when event arrives, and can you do that? And can listeners can they be stateful, have a state that they can make decisions based on? For example, there's this example of process manager for let's say you want to book a travel, yeah, and right. you need to book a hotel, buy a plane ticket, and maybe reserve a taxi. And in this example, if all of this succeed, so you bought a plane ticket, you book the hotel and book the taxi, then at the end this listener could, for example, run command to complete the order or something like that. Yeah.
Right.
But it should be able also to cancel the order if any of those requirements fail. For example, if you don't book a hotel, you don't need a plane, yeah, and taxi. And usually it's taken care of by having the stateful listeners that can have these bits of information that, for example, taxi is booked, hotel is booked, plane tickets is bought, and yeah, and is Booster able to support it?
So, I mean, I think the short answer is yes, but it would be a bit convoluted. I think you would need some kind of chain of events that would have to happen to basically say, hey, okay, like you have like a plane like reserved, and then you have like a hotel reserved, and then like
exactly.
Yeah, so you absolutely can do that, right? You can chain together like any number of event handlers and spawn these events and listen to them. So the short answer is yes. I think like the longer answer is, do we have like a kind of an out of the box solution for kind of just saying like, create Saga and then doing that? No, not yet. But yeah, absolutely. There's nothing whatsoever to say that you can't have these kind of complex event kind of operations that kind of create these different states that need to exist, and you can query different events right within these handlers, and so you might query an event of a different type or do other kind of complex logic to say, hey, am I like able to do this? Is this actually available or not? So yeah, so the short answer is yes.
Exactly. Can you is there possibility to filter out events, like for example take events only for given order?
Yeah, absolutely. So there's different event handlers for each of the events, right? And so you certainly could have a situation where for a particular handler you only care about, so like you might have like all the events that are related to let's say a question, right? But certain handlers only handle some of the events and other handlers can handle other events. So you can get as complex as you need in that regard.
Okay, thank you.
Yeah. And by the way, like I've spent a lot of time with like event-driven architectures and event sourcing, and these are like these cases are required, right? You have to be able to handle these things, and so it very much these are the great questions, and I can tell that you've built things actually with event sourcing when you ask these questions, because
basically I'm looking for a new technology to use, so that's why I'm here, because it was like perfect timing.
That's awesome.
Okay, so my next question. Oh, are there any questions in the chat? Maybe, because I don't want to. No, I think there is none. Okay, so my next question is: I see that your projections are entity based. Yeah. Basically, a projection entity. Is there possibility to skip the reduce to entity step and, for example, make like custom projection and run the SQL queries or Mongo queries manually, let's say?
So
is there like a reason for this, that those entities are part of projection process, making projection process?
Okay, so yeah, regarding the projections, well, you can. So your concern is that they're entity based, right? So you take the entity and then you project them, but you can always, if that doesn't suit you, you can always create new entities, from the events, instead of having to do maybe the trouble of going directly and running direct queries against the event store, because that to answer your question, no, it is currently not supported, because again, the framework, it's attempting to be multi-cloud and be agnostic to the underlying tool, right? So you can't put DynamoDB queries directly. That's not the, I guess that's not the idea. I don't know if that answers your question, Alan.
Yeah, but I suspect that this whole process, reducing to entity and writing to the projection, is, well, event handler based. Am I right? Yeah, because you have event handlers, and I suspect that it's all built with event handler.
Right. Yeah. It reacts to once the events start coming in, right? And there's also automatic snapshotting. So, getting back to don't have to go from the beginning of time to reconstitute the entities from the beginning of time. There's automatic snapshotting. It happens, based on a frequency of events that I think is currently like hard coded, but maybe that's something that could be optimized. And
yeah, this was my next question about snapshotting, because there can be some problems with that. I'm talking about something called cache stampede, because snapshots are more or less cache. And how do you support snapshotting when, for example, when you start the application and there is like lots of requests that run the entities that are not yet snapshot, and for example, a lot of the same entity. Is there like way to warm up the snapshot mechanism?
Warm up.
What I mean is, let's say we have an entity that has like millions of events. It shouldn't. This shouldn't happen in the. But let's say that, yeah, and you start the application, and you have lots of requests to the same entity that have this million of events. There is no snapshot yet. Yes, and those requests will basically hang on the rebuilding the entity from the events. Yeah, and do you have some mechanism, maybe comments to elevate that, to warm up the entities?
The way they're describing it, no, not as far as I know, no. Is that? Oh, go ahead, Dina.
I'd say it's on the roadmap, right? So these are optimizations, but the way we've built this, kind of when we do things in a custom way, is you either retrieve the snapshot and any events that have happened since the last snapshot, and then when you're doing the snapshotting itself, you can do batches of events, right? So you don't have to snapshot for every single event, but you can get, say, all the events that have happened since the last time it was snapshotted. I'll be honest with you, I've dealt with a lot of events. I've never dealt with a situation where I had to snapshot millions of events, but I certainly have had situations where I've built inventory applications, things like that, where the latencies are sub 10 milliseconds, and so you will maybe get and on Black Friday, you're getting 1,000, trying to like reserve inventory 1,000 times a second. So in those situations, you would get a snapshot, and then you get maybe 2 events, and then you're asynchronously creating snapshots, and you just always get the latest snapshot plus any subsequent events.
It might be a bad example of million events. Let's flip it, and let's say million requests to the same entity that don't have a snapshot yet. So it would be a good idea to have some mechanism to warm up the entities before the deployment or something like that. And
typically, like in these situations, though, I would have some kind of back pressure or some other kind of throttling mechanism to just limit like the number of concurrent requests that are coming at the same time. And so there should be something somewhere that prevents that from happening, right? Like, I mean, that shouldn't be necessarily a use case. That said, I've definitely run into situations where you have, like, let's say, like to your point, like you've created 100 events for the same entity, and then you're trying to update the entity. Now one succeeds, 99 of them fail from optimistic concurrency, and then you kind of go through that. So that's not an ideal situation, and you can use like back off strategies to say, hey, okay, I got to wait a few seconds, like things are going on, to try and to not like kind of stampede the event store, because certainly there are bottlenecks there with eventual consistency, where you do have a single writer that can actually get through at one time.
Okay, thanks. Guys, I think I hijacked this Q&A session.
Are you kidding? You made this Q&A, Alan. That was awesome. I'd love to chat more.
I still have more questions, but do we have time?
No, I'm sorry, Alan. I I think maybe it could be great. I don't know, then Mario, if you can share your contact maybe on the chat, and or maybe you can have a call, and yeah, here you have. I'm sorry. I would like to have more, but we're a bit out of time, and so yeah, maybe.
Sure.
Yeah, I would love to chat more. Please reach out, Alan. We'll set something up for sure.
Okay, sure.
Thank you very much, Alan, for all these questions. Super
Yes,
interesting.
just a second. Don't close the call. I have to copy and paste
No,
the
of course
email.
not. Mario, thank you very much. And the talk.
Now I can hear Luis. Oh my God,
You cannot?
thing is
Oh no, super weird. You can know, Dana. You're
failing for me.
I can hear you. Yeah, I can hear everybody. Yeah.
It's super weird.
Live storm.
It's not working. Livestorm doesn't want to work there. Well, it's weird. Well, no, thank you very much. Like to you to present this talk, and it will be recorded, so now all people can receive it after we close the Malt Academy. And if you agree, we can also put it on YouTube, that everybody cannot to be here today can watch it, or
yeah, let's circle offline, but I have no problem with that. I just want to confirm that everyone at the Agile Monkeys is okay with that.
If you ask me, I don't have a problem with that too.
Thank you, Alan.
Yeah, I'm gonna be famous. Thanks.
Well,
awesome.
Thank you very much, Alan. You will be maybe the next.
Thank you, everyone.
Speaker.
It was wonderful.
Thank you.
Wonderful.
Bye, guys. Bye, bye.
Bye.
Thank you very much.
Bye.